So hello students, let's see the second example of merge minimum leftist tree. Okay, so minimum leftist tree, minimum means what? The root value is minimum than its children. Okay, so the root value is minimum than its children, then it's called as minimum heap or minimum leftist tree. But leftist tree, you have to follow the property. What is the property? S value of left node is greater than equals to S value of right node. So first of all, let's check whether this is a leftist tree or not. Then I will check whether this is minimum leftist tree or not. And after doing this checking, we'll try to merge this. Okay, and merge function is basically a recursive function. Okay, so for that guys, you have to divide your page in half. Okay, so this side we will basically perform the function calling, and this side we will perform the merge operation. Okay, the merge operation means whatever the value we are getting written back, that we have to write this side. Okay, so you have to divide your page into two parts. Okay. So first of all guys, let's check whether this is a leftist tree or not. To check whether this is leftist tree or not, first of all we need to calculate the S value of all the nodes. Okay, so see, this is 50. What is the S value of this 50? That is 1. Okay, because the distance from the external node is 1. So this 50 is having, let us assume that 2 external nodes. So distance from the external node is 1. That's why the S value of this 50 is 1. Similarly for 99, 1. For 10, 1. For 15, 1. Okay, for this 20, the S value is 2. S value is, see here, this 20 is having 2 childrens. 20 is having 2 childrens, 50 and 99. Okay, and these 2 childrens having the S values 1, 1. Okay, so are same. Okay, so by the condition, what is the condition? The S value of left node is greater than equals to S value of right node. So S value of left node is 1. Okay, S value of right node is 1. So 1 is greater than equals to 1. So this is valid. This is valid. Okay, so what we have to do? The S value of 20 is minimum of S values of the children plus 1. What is the minimum value? 1 is the minimum value because both are same. So 1 is the minimum value. 1 plus 1, that is 2. So here 2 is the S value of this 20. Then what is the S value of this 25? S value of this 25 is 1. Now what is the S value of this 7? First of all, let's check whether the left node S value is greater than equals to right node left value. So 2 is greater than equals to 1. Yes, 2 is greater than equals to 1. Now let's check what is the minimum value of the children's S values. So 2 and 1, minimum is 1. So 1 plus 1, that is 2. So here the S value is 2. Similarly here the S value is 2. So here also the S value is 2. So now let's check what is the S value of 1. So the children of 1 is 5 and 7. 5 and 7, S value is 2, 2. What is the minimum of 2, 2? 2 is the minimum of 2, 2. So 2 plus 1, that is 3. So here we will get S value 3. So guys, the first tree is basically a leftist tree because it's following the property of leftist tree. Okay, let's check the first tree is the minimum tree or not. To check the minimum tree guys, first of all we need to check whether the root element is lesser than the children element or not. Okay, so first of all come here, 50, 20, 50, 99. So 20 is lesser than 50, 99, fine. 7 is lesser than 20, 25, fine. 10, 15. So 5 is lesser than 10 and 15, fine. 1, 5, 7. So 1 is lesser than 5 and 7. So that's why this is the minimum leftist tree. Okay, done. Now come to the second tree. Second tree, the S value of this 75 is 1 because the S value of this 75 is 1 because the external node is there. Okay, and external node S value is always a 0. Okay, so 1 is the S value. So S value means the distance from the external node. So distance from the external node is 1. Then what is the S value of this 22? S value of this 22? S value of this 22. So see, 1 0. So here we have one external node 0. Okay, so S value of this 22 is 1. Okay, let's check whether this is following the S values property or not. What is the S values property? The S value of left node is greater than equals to S value of right node. So S value of left node is 1, S value of right node is 0. So 1 is greater than equals to 0. That's why this is the leftist tree, guys. This is the leftist tree. Check whether this is the minimum leftist tree or not. So for that, guys, we are checking 22 75. So 22 is the small value, then 75. So it is a minimum leftist tree. Okay. So guys, up till now we have verified that both the trees are minimum leftist tree. Now guys, we'll do the merge operation. So for merging operation, what we have to check? We have to compare these two roots, and we need to check which root is minimum. Okay, so here 1 is the minimum. So what I will do, I will cut this right subtree of this 1. I will cut this right subtree of this 1 and I will call a merge function. Okay, with this left subtree. So here I will send 7. Okay, so here I am getting 7, then 20, then 25, then 50 and 99, and this tree I will get as it is. This tree I will get as it is. So 22 and 75. Okay, so guys, whenever you will draw this redraw this tree, make sure that you are drawing the elements as it is. Means like 20 is on the left side, it means 20 is on the left side. 25 is on the right side of 7, so 25 is the right side of the 7. Okay, so that thing you have to take care. This thing you have to take care. Now guys, next, what we have to do? Next, again I will compare. What I will compare? Again I will compare the roots of these two trees. So we'll check for the minimum root. Okay, so minimum root is what? Minimum root is what? 7. So now I will take this subtree. And again I will call the merge function. Okay, so 25 is here. 25 is here and 22 75 is here. Sorry. Okay, now guys, what I will do now? Again I will check the minimum. Okay, so minimum is 22, but 22 is not having any right subtree. This is null. Okay, so this is not having any right subtree. This is null. Okay, so if it is a null, guys, what it will return? It will return what? It will return null. Okay, so guys, here we are getting what? 25, and here we are getting what? Null. So this will return null. Okay, now guys, I have to do a merge operation now. Now actual merge operations going to start here, because this is a recursive function call, guys. Now we are doing a function calls only. Now we are doing a backtracking. Okay, backtracking. So backtracking, while doing the backtracking, guys, what we have to take care? Okay, so guys, while doing the backtracking, first of all, we have to identify which one is the minimum root. So here is the minimum root. So we have sent this null to the next merge call. So now whenever I will do a merging, I will do the merge on this side. Okay, why this side? Because I sent this side in the function call. Okay, and from this function call we are getting a return null. Okay, so whatever I will do a merge operation, that I will do on this side. Okay, so guys, first of all, do the merge. So here I will have 22, here I have 75, and I want to merge what? 25. So I will merge here 25. Okay, but after doing the merge operation, guys, again we have to be very careful. We have to check whether the tree, after the merge operation, the tree is the leftist tree or not. To check whether this is leftist tree or not, we'll calculate the S values. So S values for 75 is 1, 25 is 1. Okay, so 1, 1. So the S value of left node is greater than equals to S value of right node. So this condition is satisfied. Okay, what is the S value of 22? 2, because 1 plus 1, 1 and 1, minimum is 1, 1 plus 1, that is 2. So 2. So guys, no need to worry. No need to worry. So this is your leftist tree. No need to worry. So again, go up now. Okay. Now guys, this function call is over. This function call is over. We already added our element here. Now come to this function call. So see, in this function call guys, we send this value. Okay, we send this value. So whatever the value is written by this function call back, that value we have to attach here. So I will attach my value. I will attach my this tree here, because you send this value. Okay, you send this value. So let's again draw this tree. So guys, 7 we have already, 20 we have already, then 50, and then 99. And now instead of 25, I will write this tree, whatever the tree which we got during function call. So 75 is here and 25 is here. Okay. Now guys, this is my tree which I got now. Okay. Now let's check whether this tree is the leftist tree or not. So for that guys, again I will calculate the S value. S value is 51, 91, 1, 75, 1, 25, 1. Okay. Now I will calculate the S value for this 20. S value for this 20 is 2, because 1, 1, minimum is 1, 1 plus 1, that is 2. S value of this 22 is 2, because 1, 1, minimum of 1, 1 is 1, 1 plus 1, that is 2. What is the S value of this 7? S value of this 7 is 3. Okay. So 3 is the S value of this 7, because 2, 2, minimum is 2, 2 plus 1, that is 3. Okay. Now let's check guys whether these nodes are following the property of leftist tree or not. What is the property of leftist tree? The property of leftist tree is S value of left node is greater than equals to S value of right node. So S value of left node is 1, 1 is greater than equals to 1. Okay, fine. 1 is greater than equals to 1. Okay, fine. Then 2 is greater than equals to 2. Okay, fine. So no issue guys. This diagram is correct. Okay, this diagram is correct. Now again come back. Okay, next function call, we have to go back. Okay, now guys, focused on this part. Okay, so guys, whenever I did the first merge function call, in that case I send this subtree. Now whatever the tree which I got just now, that tree we have to merge here in this part. Okay, so let's try to merge. So here I am writing 1. So here I am writing 1, then 5, then 10, then 15. Okay, now I will write this tree here. Okay, so 7, then 20, then 22, then 50, 99. Okay, 75 and 25. Okay, so guys, this is the diagram which I got now. This is the tree which I got now. Now let's check whether this is the leftist tree or not, because guys, our ultimate answer is leftist tree. But if it is not a leftist tree, then we have to change the track. Okay, let's see. First of all, I will calculate the S value of 1, S value of 15, 1, S value of 50, 1, S value of 99, 1, S value of 75, 1, S value of 25, 1. Okay, now guys, 1, 1, minimum is 1, 1 plus 1, 2. So S value of 5 is 2. 1, 1, minimum is 1, 1 plus 1, 2. So S value of 20 is 2. 1, 1, minimum is 1. So S value of 22 is 2. Yes. Now 2, 2, minimum is 2. 2 plus 1, 3. Okay. Now guys, 2, 3. Okay. The minimum is 2. 2 plus 1, that is 3. Okay. Now let's check guys whether this is following the leftist tree property or not. What is the leftist tree property? S value of left node is greater than equals to S value of right node. So let's check here. Let's check here first. Okay, S value of left node 1 is greater than equals to 1. Okay, satisfied. 1 is greater than equals to 1. Okay, satisfied. 1 is greater than equals to 1. Okay, satisfied. 2 is greater than equals to 2. Okay, satisfied. 2 is greater than equals to 3. False. Okay, false guys, false. Okay, 2 is greater than equals to 3. This is false. This is false. It means this is not the leftist tree. It means this is not a leftist tree. So how I will convert this into the leftist tree then? How I will convert this into the leftist tree? So guys, whatever the merge operation I did here, I attach this tree on the right hand side. I attach this tree on the right hand side. Okay, so what I will do? I will do a swap. I will do a swap. Okay, means I will attach this tree. I will attach this tree on the left hand side. Instead of attaching this tree on the right hand side, I will attach this tree on the left hand side. Okay, so let's do guys. Let's do. Okay, so first of all I will draw this diagram. This one. Then now guys, whatever the node you have here, okay, it's a left node, but now it becomes a right node. Why? Because we are swapping the things. We are swapping the things. So 5, 10, 15. Okay. Now guys, I will merge this tree here. I will merge this tree here. So 7. Now 20. Now this is 22. Now this is 50. This is 99. This is 75. Okay, and this is 25. Okay, these arrows are very important guys. Okay, now let's write the S values of all the nodes. Again verify S values of all the nodes. So S values of the leaf node is 1. Okay, now 1 plus 1, 1. Minimum is 1. So 1 plus 2. 1 plus 1, 2. So here also 2. Here also 2. So 2 plus 2 comma 2 minimum. Minimum is 2. 2 plus 1, that is 3. Okay, so 3, 2. Minimum is 2. 2 plus 1, that is 3. Okay, now let's check whether it is following the leftist property or not. What is the leftist property? The S value of left node is greater than equals to S value of right node. S value of left node is greater than equals to S value of right node. Okay, so see, 1 is greater than equals to 1, correct. 1 is greater than equals to 1, correct. 1 is greater than equals to 1, correct. 2 is greater than equals to 2, correct. Now 3 is greater than 2. Yes, 3 is greater than 2. Now it's correct. So this is your final leftist tree. This is your leftist tree. Okay, so guys, this is how you need to solve the leftist tree problem guys. If you are having any doubt,